This is Lesson 2.1 WCS, a hot topic reading. As we're reading this article, could you please code on your paper like I'm going to be coding on the board? If you notice, the purpose or the reason why we're reading this article today is to answer the question, what is the difference between heat and temperature? Heat and temperature are two words that are often used interchangeably. However, to a scientist, they have very different meanings. Heat is a measure of how much energy there is in a system. Heat causes particles in a system to move faster. Heat energy can be transferred from one system to another in three different ways: radiation, conduction, and convection. So if you notice, there is a bolded word there. Usually if they're bolded words, we're going to circle it because it's a vocabulary word. And then I need you to underline, heat is a measure of how much energy there is in a system. Heat causes particles in a system to move faster. Usually after we underline, we need to write in the margins. In the margin, I need you to write, heat is how much energy there is. Also, you noticed that we read that there are three different ways that heat can be transferred. So I need you to put a bracket right here because these are the three ways. And I need you to write in the margin 3 ways heat moves. The first way heat moves is radiation. This is when heat is transferred through electromagnetic radiation such as light. This is how the sun heats Earth. If you notice, we have another bold word, radiation. So if you could please circle radiation. This is one way that heat moves. And again on the side, you need to write heat moves by radiation, like light and X-rays. A second way that heat moves is through conduction, which is when heat is transferred by direct contact between two objects. If you notice, we have another bold word, so we need to circle it and underline. And in the margin, I need you to write, heat is moved from one object to another when they touch. The third way that heat moves is through convection, which is when heat is transferred by movement of gases and liquids. A hair dryer transfers heat to your hair by convection. Again, we have another bold word. So I need you to circle convection and underline convection is when heat is transferred by movement of gases and liquids. And in the margin, I need you to write heat is moved by gas or liquid. Temperature measures the average kinetic energy of motion of the particles in a system. When heat is transferred to a system, the particles in that system begin to move faster, increasing the temperature. Sometimes the particles move so fast that they can move farther away from each other and a phase change happens. This is what happens on a stovetop when you are boiling water. Heat energy from the stove is transferred to a liquid water. The heat causes the water molecules to move faster, increasing the temperature of the water. Eventually, the water molecules move fast enough to enter the air as water vapor. It is important to remember that heat energy can also be transferred out of a system, like when the hot water is left on the stove to cool. Heat is transferred into the surroundings, including the air. If you notice, we have another bold word called kinetic energy. So I'd like you to circle that and then underline temperature measures the average kinetic energy and motion of the particles in a system. And if you could write in the margin somewhere, could you please write temperature measures how fast molecules are moving? And this is basically kinetic energy. And I'm going to write kinetic energy KE just for an abbreviation. I also need you to underline right here where it says the particles in that system begin to move faster, increasing the temperature. And again in the margin, I need you to write increased temperature makes the molecules move faster, and that increases your kinetic energy. So you're going to write increased temperature means faster molecules, which means increase kinetic energy. I also need you to underline the part where it says particles move so fast that they move further away from each other and a phase change happens. So if you think about it, if you draw this picture, you have a pot on a burner and it's getting warmer, right? And as it's getting warmer, the particles are going faster and getting farther apart. And as they're getting farther apart, they're turning from a liquid into a gas. So we have another bold word. It's called water vapor. So if you could please circle that. And write in the margin, water vapor is the gas form of water in the air. So is the gas form of water in the air. So again, if you look at the picture, the water's heating up, so the molecules are moving, and they're moving farther and farther apart and going faster and faster as the temperature is increasing, that you change from liquid basically to a gas, a water vapor. Temperature is measured in degrees Fahrenheit, degrees F, degrees Celsius, or Kelvin. Yes, 3 scales are used for units of temperature. The scale we use in this book for investigations is the Celsius scale, which used to be known as the centigrade scale. This scale is based on the freezing point and boiling point of water. The freezing point of water is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius. However, depending on what country you live in, you may also see temperatures in Fahrenheit, such as when you use an oven or watch the weather forecast. The International Standard Unit for measurement temperature, called the SI unit, used by most scientists is the Kelvin. Kelvin starts with what is called absolute zero, the point at which particles are completely still. This is really cold. So some important things to underline is that temperature is measured in degrees Fahrenheit, degrees Celsius or Kelvin. And on the side, I need you to write 3 ways temperature is measured. The other really important thing to underline is the part where it says the scale we use in this book for investigations is the Celsius scale. And in the margin, I need you to write used in class. Used in class. Okay, guys, that's the end of this article. Thanks for listening.